Start.
Today's lesson is about probability and counting rules. Example number 1, we are given 10 women and 7 men. The question is, if we were to choose 5 at random to form a committee, the question is, find the probability that a committee can consist of 3 women and 2 men. The way we're going to calculate this probability, again, the probability of an event occurring is your favorable outcome divided by your total possible outcome. So we have 10 women from whom we're selecting 3 at a time. We're going to multiply this by 7 men from whom we're selecting 2 at a time. So this is your favorable outcome for this ratio. Your total possible outcome, we have 17 people all together from whom we want to select 5 at a time. So to calculate this probability, we're going to multiply 10 combination 3 by 7 combination 2, and we're going to divide by 17 combination 5. So that's going to give us the values of 2520 divided by 6188. Example 2, we are given 20 parents and 5 teachers. We are to choose 4. Part A, what's the probability the 4 people we're going to choose that all teachers? Again, the probability of an event occurring, it's the favorable outcome divided by total possible outcome. So we have 5 teachers from whom we're selecting 4 at a time, divided by, we have 25 people all together from whom we're selecting 4 at a time. So it's going to be the ratio of 5 combination 4 divided by 25 combination 4. So we're going to end up with 5 divided by 12650. Part B, what's the probability that we're going to end up with 2 parents and 2 teachers? So it's still going to be the same denominator, which is 25 combination 4. For your numerator, it's going to be 20 parents from whom we're selecting 2 at a time, multiplied by 5 teachers from whom we're selecting 2 at a time. So we're going to end up with 190 times 10 divided by 12650. So we're going to end up with 1900 divided by 12650 for part B. For part C, the question is, what's the probability that we're going to end up with 1 teacher and 3 parents? Again, it's going to be 5 combination 1. We're going to select 1 teacher out of 5, multiplied by, we've got 20 parents from whom we're selecting 3 at a time, divided by always the same denominator, which is 25 combination 4. So we're going to end up with the value 5 times 1140 divided by 12650. So we're going to end up with a ratio of 5700 divided by 12650 for example number 2. Example number 3, we are given 12 resistors, and they're telling us that 3 of which are defective That means 9 of those are going to be non-defective. Part A, the question is, what's the probability if we're going to, first off, select 4? What's the probability 0 of these resistors are defective? 0 defective, that means the 4 that we're going to select are going to be non-defective. So we have 9 non-defective resistors from which we're going to select 4 at a time. Divided, we have 12 total resistors from which we're selecting 4 at a time. So the probability it's going to be 9 combination 4 divided by 12 combination 4. So we're going to end up with a ratio of 126 divided by 495. Part B, what's the probability that we're going to end up with 1 defective resistor? The fact that we're going to end up with 1 defective, that means there remains 3 non-defective resistors. So it's going to be 3 combination 1 defective resistor out of 3, multiplied by 9 combination 3, because we have non-defective resistors from which we're selecting 3 at a time, divided by the same denominator, which is 12 combination 4. So we're going to end up with a ratio of 252 divided by same denominator, 495. Part C, what's the probability that we're going to end up with 3 defective resistors? All right, so that means we've got 3 defective resistors out of a total of 3, multiplied by 9 non-defective resistors from which we're selecting 1 at a time, divided by the same denominator, which is 12 combination 4. So we're going to end up with the outcome of 9 divided by 495. Example number 4, we are given from a deck of 52 cards, we are given red face cards in the deck. That means we have 6 of them. We have 3 jacks, 3 queens, and 3 kings. And we are given black cards that are going to be ranging from numbers 2 to 9. So there are 16 of those. So altogether, we are going to work with 22 cards, let's say, in a bag. They're asking us to draw 4 cards at a time. Part A, what's the probability that all 4 cards that we're going to draw, they're going to be red? So the probability that all are going to be red, again, we have 6 red cards from which we're selecting 4 at a time, divided by, we have 22 total cards from which we're selecting 4 at a time. So the ratio is going to be 6 combination 4 divided by 22 combination 4, which will be 15 divided by 7315. Part B, what's the probability that we're going to end up with 2 red and 2 black? Again, we have 6 red cards from which we're selecting 2 at a time, multiplied by 16 black cards from which we're selecting 2 at a time, divided by the same denominator, which is 22 combination 4. So we're going to end up with the outcome of 1800 divided by 7315. Example number 5. We are given 8 science books and 9 math books. We are to select 7 at a time. The probability that we're calculating is that we are going to get 3 science books and 4 math books. Well, what that's going to be, we've got 8 science books from which we're selecting 3 at a time, multiplied by 9 math books from which we're selecting 4 at a time. divided by, we have a total of 17 books altogether, again, from which we're selecting 7 at a time. So we're gonna end up with 8 combination 3 multiplied by 9 combination 4, divided by 7 combination 7. So that's gonna give us the outcome of 56 times 126, divided by the denominator of 19,448. So we're gonna end up with the outcome of 7056 divided by 19,448.